Hi guys, and welcome to your video on Dalton, elements, and compounds. Last class we talked about the particle theory of matter and what particles were. Today we're going to break that down a little bit further and specify the different types of particles that there are. Okay, so to clarify, a particle is the single individual piece of a greater whole. Okay, so if we were in a large group of people, a particle of that group would be a single person. If you have water, one molecule of water is the particle of the water. Okay? But now I want to specify the difference, because there are two different types of particles, really. There are compounds and there are elements. And elements are even smaller pieces of a compound, but they chemically bond together to create that compound. So depending on the substance that you have, for example, if you have an element, a little tiny thing called an atom is the particle of the element. Whereas the molecule, also very small, but a little bit bigger, because it's made up of the elements, right? Bonded together. That little molecule makes up the greater compound. And so they're both particles, but a little bit different. So let me expand first here on what an element is. And it started out with this idea that everything in the universe was made up of smaller pieces, right? There were smaller units of all these things. So way back when we had philosophers, they were thinkers, not really scientists, didn't do a lot of experimenting, but they thought about how the world works. And it made sense to them that everything was made up of fire, air, earth, and water. So you can combine those different things to create anything you wanted in the universe. Obviously, there wasn't a lot of scientific fact behind that. We know a lot better now. As people started to experiment, we had these guys called alchemists come along, and they were trying to convert cheap metals into more expensive ones. So things like iron into gold. So they started experimenting, and then they started to realize that we had these things called elements because they couldn't break them down any further. Ultimately, in 1806, a man named Humphrey Davy came up with these first 6 elements. He isolated them, kept them alone, and proved that they were actually elements. So you see here potassium, sodium, calcium, magnesium, boron, and barium. You notice they're all metals. Now, I want you to write, there should be something you notice here a little bit. You guys eat sodium. You guys have heard a lot about sodium content in food. It's common in salt. Why does this sodium not look like table salt? I'm going to ask you that and have you come and answer that question for me when you come to class. Okay? So, each of these elements above are made up of millions and millions of tiny little particles called atoms. And a man named John Dalton expanded on the original particle theory, came up with this idea of the atomic theory, specific to atoms, the individual particles of elements. So these elements are made up of tiny particles called atoms. That's his first rule, number 1. Okay? His next rule was that all atoms of a given element are identical, so every single sodium atom in there is the same. That's number 2. The atoms of a given element are different from those of any other element, and the atoms of different elements can be distinguished from one another by their respective relative atomic weights. So they all weigh differently. No atom is the same weight as another. Okay? And I'll reiterate, every sodium atom, right, is the same as every other sodium atom, but it's always different than every calcium atom. So that's number 3. Number 4 states that atoms of one element can combine with other elements to form chemical compounds. So another example of a particle, right? If you look down here, water is a compound, but it's made up of the elements hydrogen and oxygen. And a given compound always has the same relative number. So this compound, water, will always have 2 H's and 1 O. If it has a different ratio, it becomes a different compound. And last but not least, we have number 5, and this is the rule that atoms cannot be created, divided into smaller particles, or destroyed in the chemical process. So there's no new atoms being presented. Okay? A chemical reaction is just a rearrangement of these atoms. So hydrogen and oxygen go from being alone, or bonded in a different way, combining to create H2O. Okay, so that's his atomic theory of matter. Now, he first proposed the idea of compounds, and that they were pure substances. So they were made up of in these joined ratios. But he didn't actually prove it. Experimentally, it was proven by Joseph Proust in 1811. So this is the idea that elements combine to create this compound. So even though he didn't experimentally prove this, he went on to determine and come up with this idea of atomic mass. right? That all the different elements have atomic masses. And he started with these first 6 and determined the actual atomic masses of them. To actually prove this idea of the fixed ratios, he used something called the Hoffman apparatus. And what this does is it just puts a chemical current, an electrical current through a chemical. So in this case, he used water. And so if we go to the video here, this will show the Hoffman apparatus being created. So this is the Hoffman, or being used. The Hoffman apparatus, you see the 2 tubes, there's water in the bottom here. We're going to set this up to the sort of a current, so an electrical current is going to run through. And then as you see here, when it zooms in, that it starts to bubble. So you're seeing this gas created. And what we know about hydrogen and oxygen is when they're in their gaseous, when in their elemental form, at room temperature, they become gases. So this produces now, when water is split up into its 2, constituent forms, hydrogen and oxygen. Okay? So again, you can see the bubbles being created. At this point now, though, you can see that the one tube has about twice as much gas in it as the other. So you can see here, this is the hydrogen, this is the oxygen. How do I know that? Well, Proust and Dalton did these experiments and realized that every time they split water up, they got one tube that was twice as much gas as the other. And they tested for these gases. And we're actually going to do those tests later in the unit to test for hydrogen and oxygen, show you how to do that. But they proved that here on the left, every time there was twice as much hydrogen as oxygen. So they were able to prove that always with a water molecule, there are 2 times as much hydrogen as oxygen. And that's where that idea of the fixed ratios and elements combining to form compounds came from. So what is an atom? We're going to go into a little bit more detail about this, but the general idea is you have protons and neutrons. Protons are these positive guys. Neutrons are the red. They have no charge. And electrons orbit them on the outside with a negative charge. So again, we're going to go in a little bit more depth there later on. I just wanted to introduce you to that. So to review, particles can be elements or compounds. Atoms are the particles of an element, where a compound, or a molecule, is the particle of a much larger compound. Okay, so make sure you answer the question here on Verso.